Today's topic, special right triangles. Before we talk about special right triangles, let's talk about right triangles in general. What are right triangles? Right triangles have a right angle, in other words, a 90-degree angle, and they are right triangles. And we will name the piece the longest side. We will call it the hypotenuse. And if you can't read that, look it up. It's easy to find. And we will call the other two sides legs. These are the special names for these things. The longest side is always easy to find because it is the side that is opposite the right angle. Now, right triangles have this incredible property, which is if you have the length of one of the legs and the length of the other leg, you can find the length of the hypotenuse. Here's the relationship. A squared plus B squared equals C squared. You have seen this before. Square both of the legs, add them together, and you'll have the square of the hypotenuse. And of course, you can work out the length of a missing leg if you have one of the legs in the hypotenuse, and so on. How does this work? Well, let's take a quick little example. I will draw a right triangle that maybe looks like a certain shape, and that shape will have 3 feet on one side, a 3-foot leg, a 4-foot leg, and it will, because of the Pythagorean Theorem, it will have to have a 5-foot other leg. Really? Does that work? It does. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. And if I told you that this was a right triangle and you didn't know the length of one of the legs, but you knew the leg and the hypotenuse, you could figure out the missing leg by using the Pythagorean theorem. Another common one that you'll see is a right triangle that looks more like this, and maybe this one will have a 5-meter side and a 12-meter side, and the hypotenuse would have to be 13 meters. Because 5 squared plus 12 squared equals 13 squared. Really? Yeah, 25 plus 144 equals 169. All right, so those are some really fancy little right triangles. You might think of them as special because they have these really nice numbers. Not all right triangles have integer sides. Some of them are irrational. But those are not the right triangles that we're going to be looking at this week. We're going to be looking at what we officially call special right triangles. There are 2 of those. I'm going to draw them. Here's the one that is called a 45, 45, 90 triangle. Why is it called that? Because it has a 45-degree angle and a 45-degree angle. And of course, that thing right there in the middle is a 90-degree angle. And then we will also study a second kind of special right triangle. Notice none of these are 3, 4, 5 or 5, 12, 13. Here's the one that has a side of 1 and a side of 2. Let's back up a little bit here. This one has a 60-degree angle and a 30-degree angle, and of course the thing in the middle there is a 90-degree angle. What do you think that one's called? If the previous one was called 45, 45, 90, that's right. This is called a 30, 60, 90 right triangle. I'm going to put RT there so you know that I'm talking about right triangles. All right, what are the characteristics of this kind of right triangle? Well, the side lengths are pretty darn special. If this is, let's make this work a little better for us here. If this is 45 degrees here, and this is 45 degrees here, then no matter what the legs are, the two legs will be congruent to each other, even though it doesn't look like that in this drawing. Whatever those legs are, the hypotenuse will be that length times the square root of 2. For example, if I have a 45, 45, 90 right triangle, let's see if we can draw it better this time. And those are angles, angle sizes. And maybe this has a length of 5 feet. Then this would have to have a length of 5 feet because every 45, 45, 90 right triangle is an isosceles triangle. Then the hypotenuse would be 5 times the square root of 2. What's the square root of 2? Well, it's an irrational number. It's kind of hard to describe except by writing it as the square root of 2. It's about 1.414. Please don't latch onto that. I'm going to be asking you for exact amounts, and those will include 5, in this case 5, and the square root of 2. Okay, let's see if we can get a nice little dividing line here. All right, let's take a quick look at the 30, 60, 90 triangle lengths. Here is my right triangle that has a 60-degree angle here and a 30-degree angle here. Well, the magical property of this is no matter what the short leg is, right? There are two legs. There's a short leg and a long leg. No matter what the short leg is, the hypotenuse is twice that. And the long leg is that number times the square root of 3. What's the square root of 3? Well, don't worry about it too much. It's about 1.732. Okay, but we're not going to be using the decimal approximation. We're going to be using the square root of 3 like that. So we'll take a little example here. If I have a 30, 60, 90 triangle, and so this is 60 degrees, this is 30 degrees, this is a right angle, and this is, let's use 5 again. If the short leg is 5, then the hypotenuse is 10. This is 5 feet, then this is 10 feet, and the long leg is 5 times the square root of 3 feet. Why does it work out that way? You should look that up. You can ask me in class too. I'll be happy to explain that. What I will be doing on this week's quiz is I will give you one of these triangles and I will say, hey, look at this triangle right here, which looks a lot like a square. Let's look at this triangle right here. I'm going to tell you that I know that one of these angles is 45 degrees, and of course I already know that the angle down there is 90 degrees, and I'm going to give you a side length. Maybe it'll be 11 meters, and I will ask you to find the other two sides. Well, the x is easy. It's an isosceles triangle, so the x is 11 meters. The two legs will be congruent. The y is easy also. It's whatever x is times the square root of 2. In other words, 11 times the square root of 2. Is that all we have to do? Would I lie to you? That is all we have to do. Don't forget this. Okay, and I'm going to draw a little tail here so you know that that m for meters is not included in there. Now, you're going to want to say, oh, well, I know that every single triangle I look at has to be a 3, 4, 5 triangle. That's not true at all. Maybe that's not a right triangle. That might be. And it's going to happen. That might be 5.2. because this is not a right triangle. And you're going to want to say, well, every single triangle I look at that kind of looks like it's an isosceles triangle, this has to be x times the square root of 2. Well, what if it's not an isosceles triangle? What if this, instead of being 45 degrees, is 45.1 degrees? And this is a right triangle. You know nothing about this until we get to the chapter called trigonometry. Okay? So don't overgeneralize. If we talk about a 45-45-90 triangle or a 30-60-90 triangle, that's what we're talking about. If we're not talking about that, then none of these rules apply. Let's do a little 45, I already did one. Let's do a 30-60-90 triangle. And you know what? These triangles don't have to sit on their bases. They sometimes could look like that. Okay? And I'm going to tell you that's a 90-degree angle. And I'm going to say to you, that thing right there has to be 60 degrees. Do I have to tell you about the other angle? No, because you know that all those angles will add up to 180 degrees. And so you will know, without me telling you, that that thing right there will have to be 30 degrees. And that's how we know that that's a 30-60-90 triangle. All right, but I will give you one more fact about this triangle before I ask you something. I will tell you, you know what? That thing right there is 21 centimeters long. Let's make it millimeters so it's easier to draw. Okay? Your problem will look like this. And I will have an X and a Y. I don't know where they'll be, but you'll figure it out. And you'll say, well, that's easy. Whatever, if I know that the short leg is 21, because that was given to me, then I know the long leg is 21 times the square root of 3, because I memorized that and practiced it during the week. And I know that the hypotenuse has to be 21 times 2. Don't leave it unsimplified. All right, so my answer, x equals 21 square root of 3 units, millimeters. Y equals 42, you can do it, 42 millimeters. Is that all we have to do? Would I lie to you? That is all you have to do. Any questions? Email me. Thanks for listening.